Okay, fourth graders, today I'm going to give you a challenge. We already used the motor and a D cell, if you had a motor and a D cell, to make the motor run, right? You can see it going. And what happened here is that we had the wire, which is a conductor, and the electricity left the negative end of the D cell. It went through the motor and back to the positive end of the D cell. So that is the pattern. Out the negative end, through the motor, and back to the positive end, okay? And we also got the light bulb to light up. And we went out the negative end of the D cell, through the wire, which is a conductor because it's metal, through the light bulb's filament gets hot and glows, and it's back to the positive end of the D cell. Okay, I want to give you a challenge to light or to make two things go at the same time, okay? So I know you have a couple of Christmas lights. Some of you have a motor. Some of you might even have two light bulbs. I want to give you the challenge to have both of them lighting up at the same time. So take a few minutes and see if you can work that out. I have this system already put together. A system, remember, is a grouping of parts that all work together. It's a piece of technology. So I have my Christmas light, and it's taped to the D cell. I have the two wires connected, and the metal is touching each other, so the electricity is conducted through. And I know it works like this because I've got it going. The light is on right now. And I know that the motor works because here it works, right? So now I want to see if I can connect these two. So I'm going to have the two pieces of metal touch each other because metal is a conductor of electricity. And I'm going to touch the negative end of the D cell. Now I see that the light bulb is lighting, but I don't hear anything from the fan. The fan is not moving. The motor is not moving. I want to check again. So if I have the light bulb alone, the light bulb lights up. If I have the motor alone, the motor works. What seems to be the problem when I put the light bulb and the motor together? The reason that circuit does not work is because it is a series circuit. And the reason it's called a series is because you can't go around the entire thing without going all through the entire system, right? So the electricity leaves the negative end of the D cell. It travels through the wire because the wire is a conductor. It gets to the motor. The motor would normally turn, right? It continues through the wire. It lights up the light bulb, and it goes back to the positive end of the D cell. So we have a circuit, and the electricity flows in that path. But the problem is this: the only way that this circuit that you can go around is to go through both of these electric converters, the light bulb and the fan. And they have to share the electricity. As a result, the light bulb says, I'm taking all that electricity, thank you very much. It allows the electricity to pass through the motor, but it doesn't do any work. So a series circuit, the light bulb and the fan have to share their electricity. This is a parallel circuit. And on the parallel circuit, each of the electric converters, the light bulb and the fan or the motor, have a direct path to the D cell, the source of energy. And as a result, they will both work. So the electricity leaves the end of the D cell, it goes through the wire, and it goes through the light bulb, It gives off light, and then it goes back to the positive into the D cell. Here's the other one. The electricity leaves the negative into the D cell. It goes through the motor, and this time, because there's plenty of electricity, the motor turns, and then it goes back to the positive into the D cell. Each of these electric converters has access to enough electricity for them both to work. They don't have to share. I want to show you a parallel circuit in real life. So Miss Ava is here to help me, and she's going to, as you can see right now, the light bulb is not working and the motor is not working because we don't have a complete circuit. Neither of them are touching the end of the D cell. So Ava, please put the motor wire onto the D cell. Okay, so here we see that the electricity is leaving the negative into the D cell, going through the wire, making the motor work, and going back to the positive end of the D cell. Now, I also want the light bulb to light up. There you go. Whoops, I need the motor to go too. There you go. So here's the light bulb. The electricity is leaving the negative end of the D cell, going through the wire, and lighting up the light bulb, and then going back to the positive end. That is a parallel circuit. Here is a series circuit. There's a series of one. There's only one light bulb, and you can see that it has a very dim light. Now, what if I want this light bulb to be very bright? I can put two batteries in a series. So I can take this battery and connect it to this one, and you can see it's very bright. What if I turn the battery in the other direction? This time, I'm going to put the D cell, the battery, in the opposite direction. So I've got the negative end of the D cell here, and I've got the negative end of the D cell here. And I'm going to see if my light gets very bright. So, no light at all, because the D cells are not oriented in the correct order. Boys and girls, if you were here in third grade, you know I love this website, fet.colorado.edu. So you're going to go to this website, and then you're going to go to simulations right there. And you're going to click on physics. So when I get to physics, I want to filter, and I'm going to go over here, and it says electricity, magnets, and circuits. I'm going to go over here, and I'm going to click there. Okay, electricity, magnets, and circuits. And now I'm going to go down to circuit construction DC. DC, this one right here. Do you see where it says circuit construction kit DC? I'm going to click on that. Now, if you want to play with this later, you can download it. You can also just play. And it has a nice little introduction about how to use the material. So I want you to see right here, over here, along this side are some parts that we can use. I'm going to just pick up a battery and I'm going to drag it out. And then you see these things here, these red circles. That's how I can connect. I'm going to have a wire, click. I'm going to click and drag a wire. And I'm going to get another wire. I'm going to click it, and I can move it around. You see how I can do that? And now I'm going to scroll down a little bit. Here's a light bulb. Oh, you know what I'm going to do, boys and girls? I'm going to move the battery down this direction, and I'm going to put the light bulb up to the top. And I'm going to take this wire and I'm going to put it on the bottom. And I'm going to take this wire and I'm going to put it to the side. And do you see what's happening? We see the light coming out of the light bulb. And we see the electricity is leaving the negative end of the D cell, traveling through the light bulb, out the side of the light bulb, and back to the positive end. So boys and girls, I added a second light bulb to my system. I just dragged and dropped it in, and if I want to break it apart, I can just click on this and there's a little X here. So you notice when the system is open, it doesn't work. When I close the system, it works again. Do you notice something different about this system now that it has two light bulbs? Okay, I added a third light bulb. Do you see that something is happening? What do you notice that is different when I add another light bulb? Every single time I add another light bulb, the light gets dimmer. What happens is that all those light bulbs have to share the one power source. But boys and girls, do you see how this time I have two light bulbs? They're sharing the same battery, but this time the light is very bright on each one. That's because each one of them has their own path to the battery. And there's all kinds of little games and things that you can play that are science related that are going to be having to do with a lot of the things we're doing in our unit. Let's do a quick little review of some of our vocabulary. Energy makes things happen, right? And chemical energy is one kind of stored energy. Energy that's stored in a battery or even an apple. Food is chemical energy. An energy source is a battery. A battery is an energy source. An apple is an energy source. Wood, coal, all of those are energy sources where energy is stored. We talked about conductors and insulators. Conductors are made out of metal and they conduct electricity. Insulators are made out of things that are not metal and they stop the flow of electricity. Today we started talking about circuits. Let's see, move this. Move these. We started talking about circuits, series circuits and parallel circuits. A series circuit is where the electricity has to be shared among all of the light bulbs and motors on one circuit. There's only one path. A parallel circuit is where every single light bulb or fan or motor has its own direct path back to the battery source or the energy source, and it does not have to share the electricity. All right, I hope you continue playing with the materials and also the PhET website. Next week, we're going to start talking about magnets.